Now, so role of the assembly code is mainly to output code for a compiler, okay, and which basically this assembly goes almost like to the level of the machine. Okay, it is just a human representation of machine code. You can think of that way, and also to write a program. Okay, in modern days, it is very unusual, but it happens that one needs to write code in assembly. Okay, we'll see why at the situation where we need to write program in assembly code, and of course in the class, since we will be using assembly language as a vehicle to understand underlying hardware, we need to program in the assembly language. Okay, we usually write program in the high level language, compiler translate it, but we also can write program in assembly language. Now, pros and cons of the assembly coding. Pros is that time critical part of a program can be made very faster with constant time response. So why do you need it? Real time operating systems. Like for example, you are making a software that controls the car, and let's say it's a brake system response. So you are writing a program which detects some objects in front of you, and then you measure the distance. Based on that, you need to automatically push the brake of the car, like car automation, for example, right? So it is very critical that this response of brake or braking of the car has to be in real time. It has to be faster. You cannot afford any lag due to some code which is written in a high level language. Now, where that problem comes in, see, the high level, when you write a high level program, a program in a high level language, it goes through a computer software program compiler which generates an equivalent assembly code. Okay, now this equivalent assembly code, there can be many solution of equivalency. Okay, so one high level code with a different strategy, we can actually create different set of assembly code which solves the same purpose. Okay, compiler as a tool, it basically kind of generalize the algorithm and optimization and all this stuff goes through that. It creates a certain set of instruction in the assembly which, if human intervene, can be made faster. Okay, with some other optimization that only human intelligence can infer. Okay, it is beyond compiler scope. So in those cases, you need to go and write code directly in the assembly. All right, and also exploit specialized instruction. Compiler tends to use more generic instructions, so that compiler implementation of compiler becomes easier, so on and so forth. So only as a human you can exploit some specialized instruction that is available in the processor and make your code faster, make your code memory efficient, and so on and so forth. In critical part of the even non real time programs, we write sometimes assembly code. Okay, a small part of it which is very critical to optimize for the memory or optimize for the time, even for the application program. We do that, we used to do that. So there are applications, not many. Okay, so maybe outside CS47 you won't be dealing with assembly code, like maybe never in your future life. Okay, maybe never. Okay, yeah, if you go in those critical roles, probably you'll need to one or two time, but that's okay. But point here is that even though in this class you don't see this language after this CS47, but what you need to understand here is this: how the underlying hardware works and behaves on your high level software program. So that is our target. Now cons, of course there are a lot of cons. It's machine specific. We learned for MIPS. You cannot say I can write for x86, right? So x86 has a different notion, different set of instructions. They behave differently, and so on and so forth. So it's very machine specific. Longer to write, of course, like one simple a equals b plus c. Yeah, I think you have seen in the past lectures or classes, like it becomes like a 4 or 5 different assembly language statement, right? So that means for a one line of high level code, you need to write 6 7 lines assembly level code. So of course it's longer to write, it is less productive, and so on and so forth. Easy to make mistake, easy to have bug, and difficult to understand, difficult to debug. Okay, so difficult to understand, difficult to debug, because if I throw you a assembly code, it's not very easy as a high level to understand what is the notion behind that programming. So of course, like then if they have a bug, it's also like hard to debug that, right? So what I generally recommend when you be writing assembly language program in this class, uh, you make a habit of putting comments, okay, as detailed as possible, so that when you need to go back for debug, you kind of remember what you were trying to do there. Okay, so commenting is very important in the assembly language perspective. And also like do very systematic programming, okay, very systematic step by step programming. Otherwise, if your program has a bug and if you did not program it systematically and test it like every almost every other code changes, then your debugging would be very hard. Like to find out a bug in an assembly program is very challenging. Okay, so whenever there is this assembly programming assignment, please take your time, do systematic development there. Okay, just don't do like maybe some of you used to do in high level language, just type some code and make it run and somehow it is working. That doesn't work for assembly language. You need to be very systematic, you need to follow the methods whatever we'll be talking in the class. Otherwise debugging is going to be a problem. Okay, so that's all for today's discussion. I hope all you understand what is meant by a programming and what computing system expect as a program, and how that language, two different language like high level to machine level language, are bridged together through the compiler and assembler. Also, you need to understand this machine language format for the MIPS, and how given assembly code you can convert into corresponding machine code.